So in B part 2, you have to find the x values of the turning points. And this is your function, and you've just figured that out by expanding the brackets in the previous part of the question. And the key point here is that at the turning points, the gradient is 0. So we're interested in the gradient, which is why we need to now differentiate the function. So this means we find the function that describes its gradient. So using our rules of differentiation, we know that 9 differentiates to 0. 9x differentiates just to 9. Minus x squared differentiates to minus 2x. And minus x cubed differentiates to minus 3x squared. So all that's happened here is that I've now differentiated this function. For any given value of x, this will give me the y coordinate, and this will tell me how steep the graph is at that point. And then the next big moment is to recognize that at the turning points, the gradient is 0. So dy by dx, our expression here, will be equal to 0, which means we're essentially now trying to solve this quadratic equation. So it's the result of our differentiation is equal to 0. At that x value, the gradient will be 0, and I will have the turning points of my function. So to solve the quadratic equation, we then have to deal with the quandary of which method we're going to use. If it can be easily factorized, then that's quick. Completing the square can be used, and the quadratic formula will always work. It's just not always the most efficient. So as a rule of thumb, it is good to have a quick look to see if you can factorize, but in the name of efficiency, if that turns out to be problematic, you can go to the quadratic formula. And the next thing to do is to make sure that if you have our quadratic formula here, that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, we do have to be really careful to make sure we get the right values of a, b and c. So a is the coefficient of x squared. It's not the first number, it's the coefficient of x squared. And in this case, that's the last term. So it's minus 3. I have to take the negative as well. Likewise, b is negative. It's the coefficient of the x term, so minus 2. And then c is positive at 9. So then it remains to carefully substitute those values into our quadratic formula. So minus b becomes positive 2. Leave the plus or minus for now. B squared is 4. And again, just to be careful, 4ac, 9 lots of a is minus 12. Is minus 27. When I multiply that by 4, I get minus 108. But because I'm subtracting, that becomes plus 108. And then 2a is minus 6. Now, because square roots can be positive or negative, I have to deal with both cases. So in the case that I'm adding the square root, I get 2 plus the square root of 112 divided by minus 6, and that equals minus 2.10 when I've rounded it to 3 significant figures. And in the other case where I subtract, I get to subtract the root of 112 over minus 6, which gives me the other x value at 1.43. And the question asks us to find the two x values at the turning points. So just to recap, this is our function. If we differentiate it, we have the gradient. So this tells me how steep it is. I know at the turning points the gradient is equal to 0. So I put my differentiated function equal to 0 and then solve it to figure out what values of x, and that's these two here, will make my gradient 0. So these are the values of x at my turning points.